This video is going to be reviewing the energy unit for semester 2. To be able to do this, you need to know the equations for potential and kinetic energy. So we use PE for potential energy, and the formula is mass times little g, which is the acceleration due to gravity, or 10 meters per second squared, times height. For kinetic energy, the equation is 1/2 times mass times velocity squared. Potential energy is stored energy, and it's due mostly to the height. Kinetic energy is energy of motion, and it's due to the speed or the velocity. So the first question in this section is, if the speed of an object doubles, then the kinetic energy of that object blank. So the only equation with speed, and here's kinetic energy, we're going to need to look at this equation right here. So if you double the speed, that means the V is going to get doubled. And what we would do, we can treat everything the same, and we can just kind of ignore the 1/2 and the M, and just consider, because we're assuming we're comparing this between what it was before and then if it gets doubled. So we're going to keep this part the same, and what we're going to do is we're going to double the V. So if I put a 2 in here and square it, you have to remember to square it, you end up getting 4. So what happens if you double the speed in the kinetic energy equation is that you're actually going to have 4 times more kinetic energy. So we would say quadruples. 37. If the height of an object doubles, then the potential energy of that object blank. So now we're going to go to the potential energy equation. If the height, we're going to keep the M and the G the same, okay? But if we double the height, then the potential energy would also double, because we're not dividing by anything, it's just straight out. So we'd say doubles. If the height of an object is cut in half, then what happens to potential energy? So now we're going to put 1/2 in for height, keeping everything else the same. The potential energy will be 1/2 as much also. What happens to potential and kinetic energy as a cart rolls down a hill? Well, at the top of the hill, you're going to have a lot of potential energy. The potential energy is very high, and if you're at rest when you start, the kinetic energy could actually be 0, right? If you got a cart and you're going to go down a hill, the kinetic energy can be low, if any. When that cart goes down the hill, what's happening is your potential energy equation, which is M times G times H, M and G stay the same, but your height's going down. So down, 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 this is going to go down. So as you fall down the hill, what happens is your potential energy goes down as you go down the hill. Kinetic energy is going to increase, because as you go down the hill, you're going to go faster and faster and faster, and that means your velocity is going up, up, up. So kinetic energy goes up. So the answer is right here. All right, if we turn to goal 6.2, this is just calculating problems using the formula. So potential energy is M times G times H. The M is 5 kilograms, G is always 10, and the height is 6.5. So if we multiply these all together, basically we have 50 times 6.5, we have 325. And that would be joules. Energy is always in joules. Calculate kinetic energy of a 25 kilogram cart. So 1/2 mv squared is the formula for kinetic energy. 1/2 times 25 times 2 squared. So 25 divided by 2 times 4 gives us 50. So the answer for kinetic energy is 50 joules. All right, calculate height and velocity. So sometimes they might give you the kinetic or the potential energy and ask you to work and solve one of the other variables. So if we're looking for a kinetic energy equation, KE is 1/2 mv squared. But in this problem, they've given us kinetic energy, 100 joules. 1/2 stays in the formula. m is 20, and we're solving for v. So 100 equals 1/2 times 20 is 10, v squared. Divide both sides by 10 to get rid of the 10 by the variable, and you've got 10 divided by 1, so 10 equals v squared. We're not quite done. What we have to do then is take the square root of 10. And it's not going to, I have to change the mode here so this calculator will work. Okay, so let's try it. Second function, 10 equals. Oh, it didn't work. Let me try that again. I might just leave this as a fun, because we got to move on. So whatever, it's 2 point something, I'm guessing. So v equals the square root of 10. Okay, move on. The next goal is using the law of conservation of energy. So the big idea with that is that you need to realize that total energy is just the sum of the two kinds of energy, adding them together, PE plus KE. So if you know potential and you know kinetic, you can add them up to get total. Conservation of energy states that if you know the total energy in one place, you know it everywhere because energy is conserved. Then you can work backwards and say, hey, if I know the potential is 400, kinetic has to be 100, so it totals 500. For part B, we know that it's at the bottom. Height is 0 at the bottom. So therefore, potential energy, which is m times g times h, if you plug a 0 in for h, then the potential energy is 0. So that means all of the energy must be kinetic at that point. The questions related to this: which position represents the point of greatest potential energy? That would be A, because the height is the greatest there. So h is the greatest. And if you look at that equation, PE is m times g times h. M and g are going to stay constant, so it's the h that determines how much potential energy you have. Which positions represent the points at which the object has the same potential energy as point B? So that would be D and F, because they're all three of them at height 0, and so the potential will be the same. Which positions represent the points at which the object has the maximum kinetic energy? That would be B, D, and F, assuming it's frictionless and no energy is lost. If we have friction, it would be the fastest would be at B. But remember, as the object falls down the track, right, all that potential energy at the top at point A is now kinetic at point B. And if you work, and that's the answer then. So at the bottom of the hill. We turn the page, the next section, you're going to use the same reasoning to fill out kinetic and total energy. So 8,000 plus 0 gives you 8,000. That means all positions are 8,000 joules of energy. And then working backwards, if we know 3,000 is potential, then this must be 5,000. So added together, they equal total. At position B, once again, height is 0. So there's 0 potential energy, so all of it must be kinetic. So now that you know these, you're going to basically work backwards to find height. Because remember, you did this already, right here, in this question, this goal. You calculated height and velocity by working backwards. You plugged in the kinetic and you solved for V. You can, oh, I guess I didn't do it here. You could plug in the same idea, put in 20,000 joules of potential energy, m times g times h. The mass is 80, g is 10, and you solve for h. So the same problem here, we're going to do it here. So you're going to take your PE is m times g times h. So if the potential energy is 8,000 joules, they have to give you a mass, and there it is. The mass is 200 times g, which is 10, and you're going to solve for h. So we're going to go 8,000, and I'm going to divide it by 2,000, which is what this number would be. So 8,000 divided by 2,000 is 4. So my height would be 4 meters. Not very tall, but okay. At B, the height must be 0 if the height is 0 if potential energy is 0. And then for potential energy here, we're going to just plug 3,000 in. So 3,000 equals 2,000 times h. So 3,000 divided by 2,000 equals 1.5. So the height here is 1.5. Same problem for velocity is we're going to do the kinetic energy, 0, equals 1/2 mv squared. So kinetic energy is 0 in this case. So this means the velocity has to be 0 because the mass is 200. The only other variable is the speed. Now for the next one, we're going to plug in kinetic energy of 8,000, 1/2 m, m is 200, so I'm going to plug 200 in, v squared. So 8,000 equals 1/2 times 200 is 100, v squared. Divide both sides by 100. That cancels out 2 zeros. So 80 equals v squared, and then I need to take the square root of it. And let's see if I can do that. So if we go second function square root, second function, back up. Try it again. Second function square root 80 equals, and this there keeps leaving it in the radical. Let me try to change it real quick. Mode. Enter. Clear. So let's try that again. Second function 80 equals, there we go, 8.9. So this would be V equals 8.9 meters per second. And then the last one, you're just going to do the same thing. 5,000 equals 1/2 times 200 is 100 times V squared divided by 100. So 50 equals V squared. So 7.1.